Hello, so we're back for some more. Right, surds and indices, another lesson, lesson 3. We had the first one in introduction. You've done one online hopefully now, and this is the other. Right, so what's our aim? To be able to use fractional indices, to be able to know the links between fractional indices and surds, and to be able to solve index equations. I bet you can't wait. Right. Fractional indices. Indices can also be fractional. For example, what is the meaning of a to the half? Using the multiplication rule, a to the half times a to the half, we'd add the powers, a to the half plus half, which is just, in fact, a to the 1, isn't it? Let's write that in. I think I want to write that in somewhere. Yeah, let's get a pen. So that's, in fact, a to the 1. And we normally just call that a, don't we? When we've got something like a equals, sorry, I'm reading something else there. A equals root a times root a. Well, we know that, isn't it? Root 3 times root 3 equals 3. But that we know. So therefore, in fact, a to the half is the same as root a. A to the half is, how are we going to write this, is the square root of a. They are the same thing. Similarly, a to the third times a to the third times a to the third works out at a to the third plus a third plus a third, which is in fact a to the 1, which we call a. But we know a equals also the cube root of a times the cube root of a times the cube root of a. And then like the cube root of 8 times the cube root of 8 times the cube root of 8 would equal 8. So therefore a to the third is the same as cube root of 8. It's cube root of a, sorry. Cube root, not a word, isn't it? In general, we just need to say, more general than that, a to the power 1 over n is in fact the nth root of a. Let's put some things into this then. What is the meaning of a to the 2/3? Well, we can write a to the 2/3 as a to the 2, or a squared, times a third. So using the rules, we can write a to the 2/3 as a squared to the power a third. So in other words, we could write it as the cube root of a squared. Or you could take it the other way around and call it a to the third all squared, or in fact deal with that, which would be the cube root of a all squared. In fact, you can write them in different ways, whichever one tickles your fancy. Right. So, evaluate the following without our calculator. We might want to draw some lines down here. Meant to be straight. Right, this one. We could write it as, probably the easiest way is to write it as 16 to the power a quarter all to the power 5. Now we know that's the fourth root of 16. So what times itself 4 times makes 16? Oh, something gone wrong. Oops, weird. And then what times itself 4 times makes 16? Well, that's 2. That's 2 to the power of 5. And 2 to the power of 5, 2, 4, 8, 16, 32. I'm right. No more of this. No silly board. That's it. No, some equals on it. Right, that down. Naughty board. Oh, I'm trying to put equal on anything. Put equal on. No, changing the pen colour. See if it makes any difference. Right, this one. So do you know this fraction? Maybe you do, maybe you don't. It's actually an eighth. So we recognise that. So to deal with the minus of all of this, we could flip the fraction and put it as a positive. So 8 to the power 2/3. Then up to you, but I'd probably do the cube root of 8 and then square it afterwards. So dealing with the third first, so the put itself 3 times makes 8. Again, it's 2, so it's 2 squared, which equals 4. And this one, similar idea, but unfortunately we have to put it as 1 over 36 to the power 3 over 2. And then what we could do, I'm not going to square that, it's far too big. I'm just square, but I'm going to cubic, it's far too big. We're going to have to do a square root. So square root, and so square it with a 2 there if you like, but you don't only put a 2. And when you do that, you can think of that as a root over 1 with the root over 36 to the power 3. Well, that's going to be 1 over 6 to the power 3. And that ends up 1 to the power 3, which is 1, and 6 to the power 3, which is 2, 1, 6. And we're done. Lovely. Okay. What is there? Right, on your whiteboard, have a go at those. Pause the video and have a go. Right, unpause the video now. If you're ready for answers, or pause it if you haven't done, and here come answers. First one, second one, third one. Hope you got them. Have a look where you went wrong if you did go wrong. Okay, if we're ready, move on. If you're not, pause it and wait a bit longer. Well, here is a summary of all the index law things that we've learned. So if you time things together, then you add the powers as long as the bases are the same. If you're dividing and the bases are the same, then you can subtract the powers. Something to the power to a power, same as finding the powers. A to the power 1 is just A, and A to the power, anything to the power 0 is 1. When A is 0, that'd be nonsense. A to the power minus n is 1 over n, a to the n. A to the power half is the root of that. A to the power 1 over n would be the nth root of A. A to the power n over n can be written as the nth root of A, the power of m, or what's written there, A to the power m, the nth root of that. So solving now equations which involve indices. We can use the index laws to solve certain types of equations involving indices. For example, here we have one. 25 to the power x equals 125 to the power 5 minus x. We should really if it was done properly, have a bracket around there. Okay, right, now what do we know about 25? Well, I know it's 5 squared. I hope you do too. That might help us. And 5 squared to the power x. And I know about 1 to 5. Well, that's actually 5 to the power 3 to the power. And we've got a power to the power, remember you just add them together, so 5 to 2x. And similarly here, we could write that as 5 to the power times 15 minus 3x. Right, now because the bases are the same, these things are equal, that must mean our powers are equal. I'll just write that down. Or indices. So we just know that from 2x will equal 15 take 3x. Get that over, you got 5x equals 15, x equals 3. Super. You can try that in the formula up there. Putting in 25 to the power 3 and see if it's the same as 125 to the power 5 take 3. You'll find it is. Okay, next question. A little one here, which is fairly simple. Again, we'll write this as powers of 5. So 5 to the power x equals 1 over 5 squared. Then we can write that, bring that to the top. So I'll put that implies, that means 5 to the x equals 5 to the power minus 2. Because the power bases are the same, the powers must all be equal. So therefore we know that x must equal minus 2. Easy, that one. Right, example 3, not so easy. Probably one or two ways to attempt it, but we'll go for it using our laws of indices. Anybody who knows about logs will know something else, but anyway. So this time I'm going to write this one as keep the bases the same. Remember, we can't divide it if the bases aren't the same. So we need to write this as x, 2 to the power x plus 1. I need this to be a 2. I'm going to have to write it as 2 squared to the power x plus 2. And we want the power around there. And this one will be useful as in powers of 2 as well. So that's 2 to the power 3 x plus 3. So we can write that now as 2 x plus 1 divided by 2 to the 2x plus 4 equals 2 to the power 3x plus 9. Right, divide and bases are the same, so we subtract the powers. So x take 2x minus x. And we've got 1 take 4, which is minus 3. Now we've got on this side, bases are the same, equal to each other. So that means the powers must also be the same. Minus x minus 3 equals 3x plus 9. Bring that one over here. So we've got 4x, stick that over there. We're going to have minus 12. And if you divide that by 4, you'll get x will equal minus 3. Super. Hard one, that one. You'll get some practice, I'm sure, in the homework. Right. What's this one? Example 4. X to the power 3 over 2 equals 8. No. To undo an nth power, we take the nth root and vice versa. So basically doing opposites for this thing. Anyway, just before we do that, we can write this thing as over half, we can write the square root of x all to the power 3 equals 8. So to get rid of the power 3, we have to do the opposite of it. So that means square root of 8, square root of x, equal opposite of powering by 3 is the cube root of 8. So the cube root of 8. So I was looking at something, I did it the other way around on the sheet. So then we'll cube root 8. So that gives us, so basically to get rid of the cube root both sides, cube root that, you get that, cube root that, you get 2. And to get rid of a square root, we're going to square both sides. That's going to end up with x equals 4. Right, a whiteboard question for you now. Have a go at that one. Pause the video for as long as you like to get it done. That doesn't mean go for an hour and do something else. We're nearly at the end, I promise. So if you've unpaused, oops, here is the answer, x is 2. You need to see a bit of working out, that's one way of doing it. Okay, right, I think there's going to be some homework for you. Have a look at the homework email. I don't want to give you any extra on this. I'm sure you'll be tested in what's on there. Okay then, right, that was a short one, wasn't it? I shall see you in lesson next week. Super. Bye bye. Oh, I'm breaking something. Oh, before I say bye bye, gosh, I got confused then. We've got a harder check question here. These are quite vile, so these will really challenge you. Pause this video, have a go at these. First one says, solve the following mathematical equation to get the value of y. You might not like this, but you can have a go. It's not a very nice answer for number 1. It ends up as solving a quadratic and giving a decimal answer. But it's still fun. Number 2 works out as a nice whole number or value, if I can remember rightly. So have a go at them. Have a go at them and see what you think. Please pause the video because it will take longer than what I'm going to let you have now. But here are the answers. I don't spoil it. As I said, this was number 1. Hopefully you can see what I did. You end up getting a quadratic. And that quadratic isn't nice to solve. We did this right. I think I did it right last year. And it gave me those horrible numbers. I'm very sorry about that. You could solve quadratics with the calculator if you've got it. If you manage to get this thing from the menu, again, you never get these things in line. From the menu, if you choose equation, you press polynomial degree, that means the highest power, 2, and then you can pop in, if you look at the bottom, a, b, c equals 0. You pop in 1, minus 3, minus 2, and then press the equals, and it actually gives you those things in some sort of Surd form. Ooh, dear. If you can snap up, I'm in the right place. I don't think this. Actually, come in focus, does it? So if you want, you could have written these interesting answers as that one is 3 plus root 17 over 2, and this one is 3 minus root 17 over 2. You can also get the answers to this if you want to do nice and Surd form. You get them from doing that form, if you remember. What was it now? I forget. So b squared. Over here. I can't remember. Is it b squared? I have to sing the song. So it's minus b plus or minus square root squared minus 4ac, b squared minus 4ac over 2a over 2a. I think I remember it. A bit odd, but never mind. Okay, so you could have solved the quadratic using that form. If you remember that, we put y equals x equals y. Question 2. Here are the answers to that. I'll give you a nice little answer of 5, 6 there. I'm sure that one would have given you a bit of fun if you tried it. Hope you can follow it through. Right, I'll leave you to peruse that. I'm off for a cup of tea, and I'm sure you might be off for something else. And I shall see you next week in lessons.